Alright, so I'm going to be going through the Homework 7 Office Hours Q file. And the main way to complete this file is you need to have a pretty good understanding of what a struct is. And so a struct is just a custom data type that's usually a composition of smaller data types like integers and even other structs, really. You can kind of like have this tree structure of structs where like this struct, one of its childs is a struct. When we look at student data, even that struct has another struct child on it, so you can get really you can make really sophisticated structures, very meaningful types by using structs. But I think the best way to understand structs is just to map out how the memory looks like. And so right now we have big struct. Back to red here. A pretty big struct here. I'm just gonna make a pretty big rectangle. Space. And so what is a struct composed of? Well, it's composed of an array of 30 integers. And let's just assume, it depends on the system, but let's just assume a size of int equals 4. What you're going to have is you're going to have 120 bytes of integers. And I'll just make a boundary. That's probably going to be the majority of the struct. Make a pretty big cutoff here. This is going to be your custom ID. This variable is a big array of 120 bytes. And then right below that, looks like the next thing is just a one singular int Q number. So let me very tiny slice. Call that Q number. And then below that we have our struct student data. I'm not actually sure how big this is, so these little segments I've made might not be proportionate. But I know this is going to be 4 bytes based on our assumption. So what's actually inside the student data? Like, let's open it up and let's actually see. So where is the struct student data? Looks like it's over here. Like all it's comprised of is, and let's write this sides. Let's just say in blue here. How is this student data organized? Well, it looks like the majority of it is car name array, and I'm going to make a guess that that's a little bit over half the size of the struct. Right segment here. We'll name that as our name. Make that blue. Name. And that's going to be 30 bytes. Because size of one character will always be 1 byte. That's one of the guarantees of C. And then the next thing is a struct topic. I'm not actually sure how big the struct topic is yet, but I'll write it down. Topic. You kind of see I've broken down student data into a name and a topic. But I need to further break down this topic because there's another struct. So if I go to topic, looks like it's over here. This is how topic looks like. We'll do that in green, I guess. How is that broken down? Well, it looks like there's just an enum, topic name, and a float question number. And so I think an enum is actually stored as an int. So I'm going to just treat it as 4 bytes. I might be wrong, but I'll assume it's 4 bytes. And I think a float is also 4 bytes. So let's split up like this. We'll have a topic name. Screen real quick. Name. And we'll have a question number. And that's actually, I believe, the whole structure. So I'll write the number of bytes as well, 4 and 4. And assuming these, I did the math right, or these are, I'm making a lot of assumptions here about sizes, but math is right, and that means our student data is should be, I believe, 30 plus 4 plus 4, so I think it's 38 bytes. And our topic is just 8 bytes, so this one would be 8. Blue. That's 8 bytes. And so yeah, I think we've mapped out the whole memory of how a student looks like. And so how can we start putting and taking stuff from these little spots here? Alright, so first let's make a student. So make a struct. And know that struct is actually a part of the name. When you're making a new struct student, you actually have to write out the whole struct student. And so what we did was we kind of initialized some spot. Basically told C to, when you call this function, we build up the stack, give around 162 bytes of space in that stack frame to basically hold all the members of the struct. And right now it's actually all going to be garbage data, but you can assume this will all be on the stack, right? And that's what all this line of code did, was do that for us. A lot better than assembly, right? 162 bytes in the stack. You'd have to add really a pretty big number to your add R6 like usually it's add R6 offset 5, right? Well, it'd be something a lot bigger in this example, like maybe like minus 100 something. I'm not sure. But yeah, that's what this line does. And so now, let's say we want to set our queue number to 5. Oh, we can actually do that by doing s.queueNumber equals 5. That's going to take this 5 and place it right in that little slot for us, that 4 byte slot. Alright, well, what if we wanted to set custom ID for the index 4 of custom ID to, let's say, 7? We do that by doing s.custom ID. Oh, forgot the semicolon. s.custom ID equals 7. Well, S4 equals 7. What that does is finds that little 4th index of custom ID, maybe somewhere right there. It'll place that 7 right in that slot. Alright, so how can I navigate into these deeper children here? Well, let's say if I wanted to access question number, how could I do that? Well, I'd have to see question number's parent. It looks like it's topic here. And then from topics parent is student data. So I'd call s.studentData. And I can just basically trace how to get there from looking at this little diagram. Go narrow in on topic, and then from there we narrow in on question number. And I can set that to 1.7 or something. That's just going to take this 1.7 and place it right in that little slot for me. And that slot is really kind of this slot over here. We'll take that 1.7. It's going to live somewhere around this area in student data. Okay. And then, what about name though? So this name, notice, is a character array. And so what you really have to do in C is, I can't just set the name to like a pointer. Like, we're given a pointer here. Let's say that's x4000 is pointing to like H E L L O, and the null terminator. Okay, I can't just say something like this: s.studentData.name equals student name, pointer right there. That's just saying like s.studentName equals x4000. It doesn't really make any sense for an array to have this little value of x4000 pointer. Right? An array isn't a pointer. It's not going to have a memory address. Okay? Like x4000. So this is not valid. So what we actually have to do is we have to individually set every little character all 30 of them, kind of like in a loop. And I believe you guys have this implemented out. You've probably already done this in my string copy. And so what we're going to do is you're going to pass in the array here. So s.studentData dot name. And this is our destination array. So this is where it's going to copy to. And then here, now we're going to set this to our student name pointer. Basically, it's x4000. And we have to specify a length. You can use your handy myStrlen function. It's going to be the length of your student name, and you also have to add 1 for the null terminator. One thing I want to mention is that this is actually my string copy takes in a pointer. So how are we allowed to pass in an array to a function that takes in a pointer? Well, there's a saying in C called arrays decay into pointers. And so when you pass in an array, C is smart enough to know to convert that array to the pointer of its base address. Alright. So although arrays and pointers are not the same thing, arrays can decay into pointers. Because they're kind of inherently related to pointers, right? Because they do have this base address. And so this my string copy is just going to take this H, it's going to place it right there. It's going to take this E, it's going to place it right there. Take this L, it's going to place it right there. All the way up. And because of this +1, it's also going to even copy the null terminator over. Really nice. That's exactly what we needed. So I'll just all that stuff. Okay, great. And what about topic name? So that's actually an enum. But you don't have to treat an enum any special. I would treat an enum kind of like any other primitive. I would just do s dot like student data dot. Looks like it lives in topic, and then topic name. I can set it equal to one of these topics and set the assembly. I can set that to LC3 as well if I want. So yeah, hopefully this kind of helps navigating stuff. And that's all it's going to do is going to take this LC3, going to place it right there in topic name, which really lives right somewhere in there. So, and what's the actual value going to be? I actually believe these enums are represented as ints. I think its assembly is 0, LC is 1, C is 2, L is 3. So if I picked like LC3, I think it's actually straight up store 1 there. You might want to fact check that. But yeah, I hope that helps with the homework. And just know that this isn't sufficient enough. You have to check for edge cases. So I would read the PDF. I believe there's one. This is the case where this student name fits into this 30 length array. Sometimes it might not. So I would double check the PDF. Alright, hope this helps.